Welcome to this video. In this video, we'll be solving the question on 3D geometry that came on JEE Mains 2026 on 21st Jan, Shift 1. This question is, let alpha, beta, gamma with the coordinates of the foot of the perpendicular drawn from the point 542 on the line R. The line R is given. The length of the projection of the vector alpha I plus beta j plus gamma k on the vector 6i plus 2j plus 3k is. This is a two-part question. On the first part, we need to find the foot of the perpendicular. Foot of the perpendicular is alpha, beta, gamma. The next is we need to project. The next part, we need to project the position vector of the foot of the perpendicular towards another given vector 6i plus 2j plus 3k, and we need to get that projection. Okay, let's get started. We'll bring the 3D space. We will add our given line to our animation. So this is the given line R minus I plus 3j plus k plus lambda into 2i plus 3j minus k. This is our given line R. Now we will add the point, the given point 542. The point 542, the perpendicular line, that is a perpendicular line from the point 542 towards the line R is also added, and the foot of the perpendicular alpha, beta, gamma is present. Now let us solve to find alpha, beta, gamma. So line R is like this. We can also write line R in another form. So let us write line R in another form, that is minus 1 plus 2 lambda. It is 3 plus 3 lambda. The y coordinate will be 3 plus 3 lambda. 1 minus lambda. Okay. So any point on R can be categorized as this one. So let our alpha, beta, gamma point, that is the foot of the perpendicular, be this point minus 1 plus 2 lambda, 3 plus 3 lambda, 1 minus lambda. Let the alpha, beta, gamma be this one. Now we need to solve for alpha, beta, gamma. For that, we will be using the perpendicular property, that is dot product of the direction ratio of this line. Direction ratio of the line R is 2, 3, minus 1. Dot product of 2, 3, minus 1 with the direction ratio of the perpendicular line is 0 because both are perpendicular. So dot product of this perpendicular line is alpha minus 5, beta minus 4 and gamma minus 2. But we have considered alpha, beta, gamma is this one. So direction ratio of perpendicular line is minus 1 plus 2 alpha minus 5, that is minus 6 plus 2 lambda, it is lambda, 3 plus 3 lambda minus 4, so minus 1 plus 3 lambda, 1 minus lambda minus 2, that is minus 1 minus lambda. This is the direction ratio of the perpendicular line. So dot product with 2, 3 minus 1 is 0. So let us do the dot product. That is minus 6 plus 2 lambda minus 1 plus 3 lambda minus 1 minus lambda, and dot product will be 2, 3 minus 1 is equal to 0. So let us solve for lambda now. So that is minus 12 plus minus 12 lambda plus minus 12 plus 4 lambda minus 3 plus 9 lambda plus 1 plus lambda is equal to 0. Minus 15 is minus 14 4 13 14 plus 4 lambda is equal to 0, which means lambda is equal to 1. If lambda is equal to 1, then the foot of the perpendicular, we have considered this as the foot of the perpendicular. So if lambda is equal to 1, then alpha will be, from here we can write alpha is equal to minus 1 plus 2 lambda, that is minus 1 plus 2 1 beta 3 plus 3 6 gamma minus 1 1 minus 1 0. So foot of perpendicular is 1 comma 6 comma 0. So here we got the value of alpha beta gamma. Let's add that here. Alpha beta gamma is equal to 160. So the first part of the question is over. Now we will proceed to the second part. Let's go back to the question. Second part is length of the projection of vector alpha beta gamma on vector 6 2 3. So we will add the vector. So this is the position vector towards alpha beta gamma, and this vector, that blue vector here, is alpha I plus beta j plus gamma k. Let us add the second vector. So the red vector is 6i plus 2j plus 3k. Okay, we got the two vectors. Now we need to show the projection of the blue vector towards the red vector. See here. So we are interested to find the projection length, that is the length. If you are drawing a perpendicular from this point to this, then this length is the projection length. How to find that? So projection means, if your projection length means we need to dot product it, then we need to divide by the magnitude. So we will, let us say vector A is our alpha I plus beta j plus gamma k, and vector B is, alpha I beta j gamma k is, right now alpha is 1i plus 6j plus 0k. Then our vector B, let it be 6i plus 2j plus 3k. 6i plus 2j plus, this plus or minus, plus 3k. Plus 3k. Then projection of A on B is A dot B divided by magnitude of B. So that will be, doing dot product, it will be 6 plus 6 into 2, 12, divided by magnitude of B is nothing but square root of 36, 6 square 36, 2 square 4, 3 square 9, that is 18. Here 36 plus 4, 40, 49, root of 49 is 7. 18 by 7 is the answer to this question. So let us summarize. First part is foot of the perpendicular. We got the line R was given, the point 542 was given. We found out the foot of the perpendicular alpha beta gamma. Then after that, the two vectors, and we have found out the projection, and we solved the question. So that's all for this question. Hope everybody understood it. See you in next video.